Here's an introduction to calculus. First of all, the word calculus just means to count by rocks. That seems pretty simple, doesn't it? Well, most of the skills are at year 11, but knowing how and when to use them, that's at year 12 level. So that's what we're going to be learning, because basically we just do a little bit of multiplication, a little bit of subtraction, and a little bit of changing the variables. Differentiation and anti-differentiation are the two major parts on this one, and this unit standard, achievement standard rather, and that's worth 5 credits. So it's important we come to understand. We're going to look at how and why we do differentiation in this one. Integration is another name for anti-differentiation. So we're looking at how and why. First of all, how. How do we differentiate? They're basically two steps. Multiply by the power and reduce the power by 1. Just remember that, those two steps. Here are some examples. Y equals 5x squared plus 2x. We're going to differentiate it. Note that y dash stands for differentiation, and I use a different colour pen because they're completely different equations. Multiply by the power. 2 times 5 is 10. So that's why the power, that's why the 10 comes at the front. We reduce the power by 1, and then multiply this one. 2x just comes down to 2. The reason is that 2x is the same as 2x to the power of 1. When you multiply by the power, you have to reduce the power by 1, and x to the power of 0 equals 1, so the x disappears. Remember, we're reducing an x, so an x squared goes down to an x term, and x goes down to a number goes to 0. So in the next case, here we're going to differentiate this one. 4 eighths are 32, so it's 32, take 1 off the power, so x4 goes down to x3. A number disappears, so that term will be 0. The reason is that 7 equals 7 times 1. 1 is the same as x to the power of 0, and when I multiply by the power, I multiply by 0. So that term will disappear. And the next one, negative 1 times 3 is negative 3x. Take 1 off the power, and we've got an extra plus in the middle which we don't need. So that's the second step, differentiate it. 8x4 goes to 32x cubed, the 7 disappears, and the 3x to the negative 1, negative 3x to the negative 2. Why do we differentiate? This is really important you remember this, because the questions won't necessarily tell you. But we differentiate to find a gradient, to find a rate of change, to find a tangent to the curve, and to find your maximums and your minimums. To maximize the profits and minimize the costs, that's where we apply them to questions. So we need to recognize those words. If the question asks you for a gradient, differentiate. If it asks you for a rate of change, differentiate. If it mentions a maximum or a minimum, differentiate. If it wants a tangent, differentiate. So you need all of those in your head. You need to learn them to apply them to the question. And if you don't learn this slide and the previous one on how, then you're not going to get very far in getting your 5 credits. So, find the gradient of this curve at the point 2, 1. The key word here is gradient. We just learned that if you ask for the gradient, differentiate. So let's differentiate this. Y dash is 2x. Now, that's the gradient function. We're asked for the actual gradient. We know what x is, so we put 2 in to replace x, which gives us a gradient of 4. Now the next bit I'm going to show you is not necessary for this question, but just to help you understand. There's the curve y equals x squared minus 3. We want to find the gradient at the point 2. So I've shown you where 2 is. We know that the answer says it's 4. So there's a tangent with a gradient of 4. If I move this tangent closer to the curve, and closer still, it will actually hit the curve at the point 2. So there we go. That's how that works. So we've found the gradient of the curve at the point 2. At different places, this curve will have different gradients for the tangent. For the next example, we often need to simplify our terms before differentiating. For example, y equals 4 over x squared. We're going to change that to y equals 4x to the negative 2. This is where some good algebra skills come in handy. Multiply by the power, take 1 off the power. That's the same as negative 8 over x cubed. The next one, expand that out by FOILing. Here I've multiplied the second bracket by 3. Then I multiply the second bracket by x. Differentiate that, it gives you 6x. The 3 will disappear, a number goes down to 0. 3x squared plus 1. X goes down to a single term. 1x is the same as 1 times 1. When we take 1 off the power, x to the power of 0 is 1, so it all disappears. This one, change the square root of x to x to the half, and then multiply by the power. Now dy over dx is the same as y dash. So there are different ways of showing how to differentiate. This is called Leibniz notation. Probably pronounced it wrong. 3 times a half is 3 over 2. X, reduce the power by 1. A half minus 1 is negative a half. And that's what it looks like. And you can put the square root underneath if you're that good. So there's the introduction to calculus, differentiation. Watch out for the next tutorial.